All right, this video is going to be dealing with some more trigonometry, dealing mainly with your angles of elevation and depression. These are going to be involved in a lot in our word problems. The first thing we want to talk about is the line of sight. The line of sight connects the observer to an object. Your line of sight, it could end up being horizontal, it could be diagonal. It's basically where you're looking at, where you're looking towards that object. The angle of elevation, what we need to see here is the word elevate. It means to go up. So this is going to be the angle formed by an upward line from your line of sight and horizontal line. So what that means is right here where you see angle of elevation, we're going from the horizontal line to your line of sight upward. That would be the angle of elevation. So it's going to go from a horizontal line upward. And the other one is your angle of depression, which the term depression, means psychologically, means kind of be down. So that's where you can think of this is going to be your downward line of sight. So it's going to go from the horizontal line right here downward. Okay. So let's look at these in the next diagram we have. We're going to label these angles, or label the angles in each diagram as elevation or depression. So here's our horizontal line, okay? And this one is showing us looking downward to that diagonal, or the line of sight. So since we are going downward, we have angle of depression. Down here at the bottom, here's our horizontal line. We are going to be looking upward at our line of sight. And so since we are going up, we are elevating. This is our angle of elevation. Hopefully I'm spelling that right. When we look at the other, which changes, we're looking in different directions. The first one, we were looking left at the top one. Now we're looking right. We need to understand that the horizontal line right here, going down to the line of sight, downward. So here is our angle of depression. So we see from several different views. Here's your horizontal line at the bottom. To go up to the line of sight, we're going to look, like I just said, up to the line of sight. We're going to go upward, which will be your elevation. There is a note right here to let you know that most often your angle of elevation and depression can be congruent. And we'll see this later on. We're looking at some word problems. We're going to round each of these to the nearest whole number as our notes tell us here. Okay, so we'll keep that in mind. Nearest whole number, I'll highlight that. A lot of times the angles, we do that anyway. So we're going to go ahead and we're going to take a look. We've got this story. So I'm going to draw these cute little pictures. You guys are going to see how great of an artist I am here if you're not one of my students. We're going to have a space needle. Now, a space needle is a big tower. People stand at the top. So I'm going to draw my space needle. Here it is. And I don't know what it looks like. Sure, that looks good. It's a tower. Okay, it's got a little needle on top. The space needle casts a 67-meter shadow. So we need to understand where this shadow is. Shadow is going to be on the ground. Okay, so this is going to be our shadow. And it is 67 meters. If the angle of elevation from the tip of the shadow, meaning over here, shadow, I know don't get confused, tip of the tower, tip of the shadow right here, to the top of the space needle is 70 degrees. How tall is the space needle? So what we need to look at is we're going to be standing here at the tip of the shadow. We're going to be going up to the top of the space needle. Our angle of elevation, so there's that word elevation telling us up. It's going to be right here, going upward. It's telling us it is 70 degrees. We want to know how tall is a space needle. That tall tells us we're looking at height. So here is our x. Okay? So now we take a look at, all right, what sides do we have? So we can look at our SOHCAHTOA. We can look at it. We're using sine, cosine, or tangent. And here, knowing that our building and our shadow will always be the 90-degree angle. So this line of sight right here, going upward, is going to end up being the hypotenuse. So across from the angle of elevation is going to be our opposite on the opposite side. And right next to it, the shadow is our adjacent. So we have O and A. And if we remember back, that would be tangent. So the tangent is opposite over adjacent. Okay? So we're going to set this up. We have our equation, trigonometric equation, tangent of our angle measurement 70 is equal to opposite x over adjacent 67. And we remember with our shortcuts, when the x is in the numerator, we multiply. So all we're going to have to do here is just cross multiply these, and then we'll end up with x equals, on our calculator, we're going to type 67 times the tangent of 70. And for those of you who have not seen the calculator that we want to use on our phone, you're going to want to download the Desmos Scientific Calculator, which is going to be this one that says the cube root of 27. And with this, we're going to type in 67, and then times the tangent. So we'll put times, go to your function. Functions, we're going to find the trigonometric functions. We have the tangents. We're going to type in tan. Just click that button. Go back to the main, and we're going to type in 70. And then there's our answer right there. We can either look at it or we can press enter. And rounded to the nearest whole number, x will be approximately 184. Reason is because we have 0.0, and we were looking at that 4. The 0 tells us to leave that alone. So this is going to be our final answer. And we can label it as meters if we want to. All right, let's take a look at another one. The pilot of a traffic helicopter is tracking an accident on the road at an angle of depression at 18 degrees. If the helicopter's altitude is 1,560 feet, then what is the horizontal distance from the helicopter to the accident? Now, if you scan this QR code, it will give you a diagram, kind of like these right here, but it'll be more detailed with the actual pictures to help you out to see what's going on. But I'm just going to go ahead and draw these out for you because you guys love my artwork. So we have the pilot of a helicopter. He's up in the air somewhere, all right? So here goes the helicopter. Here's our helicopter, right? Go, shoo, shoo. All right, perfect. Looks great. Everybody agrees. This helicopter is tracking an accident at an angle of depression of 18 degrees. So we're going to have this little accident over here. I don't know if it's a fire or what's going on, okay? The angle of depression, so here, this is going to be where he goes. Here's his line of sight right here, okay? That's where he's looking at. The angle of depression is going to have to come from a horizontal line, if you remember right here. Okay, we've got a horizontal line that's going to go up or down to our line of sight. So we always go the horizontal line straight out. So our line of depression from the horizontal line down to where he's looking is going to be 18 degrees. The helicopter's altitude, first let's go ahead and highlight this depression and write down. Remember, we're looking downward to our line of sight. The helicopter's altitude, remember, altitude is going to be your height. So we're looking at how high up that helicopter is 1,560 feet. We want to know the horizontal distance from the helicopter to the accident. So there's a couple different ways you can do this. Okay, you could just say, okay, draw this line right here. It's the same. What we're going to do is we're going to go ahead and look at this horizontal distance, and that's going to be our x. On the other page, it said that note that the angle elevation depression can be congruent. So this horizontal line to the line of sight and the bottom horizontal line up to the line of sight, the elevation, are both 18 degrees. So then we can just focus on the triangle down at the bottom. Here giving us our 90-degree angle, all right? So we see here that from our reference angle, okay, angle perspective, opposite side of the triangle is going to be the 1,560, and then adjacent right here next to it is going to be our x. O and A, opposite and adjacent, is our tangent, so we will be using tangent equals opposite over adjacent. A lot of times we use tangent with angles of elevation depression, not always though, but I've noticed a lot of problems do that. We'll see one here in a little bit that is not. So let's set up our equation. The tangent of your angle, 18 degrees, is equal to opposite, 1,560, over adjacent, x. We see here that we have x in the denominator. X in the denominator divide. So we're going to take these two and switch them. So we will have x equals, we're going to have 1,560 still on top, but now the tangent of 18 and x have switched places. So here we have tangent of 18 on bottom. And so all we have to do is plug this fraction into that calculator. Okay, and again, if you are at home, all we need to do here is we need to press this AB fraction function over here to get a fraction. We have 1,560 on top in the numerator. We're going to tap down on the denominator. We'll get there eventually. Let's see if I can get there. Nope. I know you can press buttons and it'll go eventually. There we go. Eventually you'll get there. Tangent of 18, go to your functions, type in tangent, go back to main for your numbers and type in that 18. And there you go. We're going to round to the nearest whole number, giving us that x will be approximately 4,801. Because we have 0.1, the second one tells us leave that first one by itself. All right, please rewind if you need to. Pause if you need to. Now our next problem, we have a flagpole. Okay, so I'm going to go ahead and draw in my flagpole. And you guys are loving this artwork. This is probably my best one. Right here, the flagpole. It has an 8.7 meter wire attached diagonally from the top, okay, up here at the top, to the ground. So it's diagonally. That right there tells us we're going to go diagonal. And this wire is 8.7 meters long. Okay. The pole is 7.4. So here's your flagpole, 7.4. We need to go ahead and complete the ground here so that the wire is attached to something, the ground, given our 90-degree angle. So we're going to have here, what is the angle of elevation? So now we're going to use the inverse trig functions, but we're looking at elevation for up to the top of the pole. So we're going horizontal line of the ground up to the line of sight, which is going to be that wire. We're looking for this. So this is going to be our theta. So in this problem, we need to figure out what function we're going to use first. Here is our reference angle or angle of perspective. First of all, I see I'm using my hypotenuse across with a 90-degree angle, so I have h. From this angle, angle of perspective or reference angle, the 7.4 is on the opposite side, so I have O. And if we remember our SOHCAHTOA, our trigonometric functions, O and H go with sine. So we're going to have sine equals opposite over hypotenuse. So now we need to remember that we are missing the theta. So there are two different ways you can do this. We know we're going to use the inverse function, so if you want to skip straight to it, we can just say our theta is equal to the inverse sine with that -1 exponent, okay, of opposite 7.4 over hypotenuse 8.7. So we go back to that calculator, and we're going to type in first the inverse sine. So we go to the function, inverse sine, second row, all the way to the left. Go back to main. We're going to press the a over b fraction function, put 7.4 in the numerator, tap down, if it's going to let me this time, and put 8.7 in the denominator, and there we go. Now, we want the nearest whole number, so theta will be approximately, we have 58.2, so that 2 tells us leave the 8 alone, so approximately 58 degrees. The last one here, we have a ship sailing, so I'm going to draw my little ship, and it's got a QR code also, you can look at a diagram of the drawing. It is 3,280 feet above the ocean floor. So here's the ocean floor. Here's the ocean. Okay? So the height above this ocean floor, where we create that 90-degree angle, is 3,280 feet. So So they're searching for a sunken treasure, right? Let's just say, I'm just going to draw a little star here. That's treasure, right? Golden star. This is searching for this, so you know that your line of sight is going to go downward this way because you're looking at that treasure. So now we have our triangle. The distance, the horizontal distance from the ship to the sunken treasure, okay, which you can look at up here, is 4,000. Now, this is what I wanted to show you. We can also transfer that 4,000 down here. These will be the exact same, okay? Or you could just label it down here on the ocean floor. Then, if that's going to be the distance, then what is the angle of depression? So we're using the inverse again. Depression here, we have down. So we are looking here, but remembering that our angle of depression right here will be the same as your angle of elevation on the other side. We do have alternate interior angles going back to transversals, okay? So as this will be our theta, so will this. And then we can just use this section right here. So taking a look, I'm not using my hypotenuse. So at our reference angle, I have opposite. And I have right next to adjacent, using tangent again. Opposite over adjacent. So again, when we're missing our theta, we can just slap in the inverse trigonometric function. So the inverse tangent of opposite 3,280, it's going to be a lot of typing in the calculator, over adjacent 4,000. You can always simplify these fractions if you want to. Okay, I have not been. And we're going to plug this in and round to the nearest whole number. So here I'm going to use I'm going to go to function, go inverse tangent with the -1 exponent, back to main, a over b for a fraction, 3,280 over 4,000. And here we have 39.3. The 0.3 tells us leave it as 39 degrees. So this will be approximately, we haven't any rounding ones on there, approximately 39 degrees. Again, you can use those QR codes to help you with the diagrams if mine are not pretty enough. All right? Ask your teachers if you have any questions. Hopefully this helped.